All right, guys, we're going to start off with a little bit of review and kind of hopefully see how that connects to our new material. So, um, first thing I want to do, we just want to evaluate each one of these logs. So, when I look at this log right here, log base 4 of 64, what this is really asking is 4 to what power equals 64? So, how many 4s do I have to multiply together to get to 64? Well, 4 times 4 is 16 times another 4 is 64. So the answer to this is 3. 4 to the third gives me 64. Okay, let's look at this next one here. Log base 2 of 64. So again, the question is 2 to what power gives me 64? So I literally still do this on my finger, so I'm going to count these out. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. That was 6 2's. That gives me that answer. And last one, hopefully nice and easy. Log base 2 of 4. That's asking what power of 2. So 2 to what power equals 4. And hopefully we all know that is 2. So what I want to show you is the relationship between these answers here. And we're gonna do one more example just to give you a little more practice with logarithms, and then we'll kind of come back to this. But I want you to recognize, look at the answer here, log base 4 of 64. The answer to that is 3. And then the answers to these other two, which look pretty close to our original problem, are 6 and 2. Okay, so let's check out this next one. Next one, log base 9 of 81. So again, 9 to what power gives me 81 is the question. And the answer to this one is 2. So 9 squared, because 9 squared gives me 81. So the answer to that one is 2. Log base 3 of 81. So let's count it out. 3 times, or 3 to what power equals 81? Well, 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So the answer to this one is 4. 3 to the fourth gives me 81. And last simple one here, 3 to what power gives me 9, and that's 2. And so we have all of these, we've evaluated all of these logs. And so again, let's look at the results that we get here. So the result of this one is 2. Log base 9 of 81 equals 2. Log base 3 of 81 is 4. And then log base 3 of 9 is 2. And look at the relationship between these answers here. And let's just kind of think and go back here. Think about the relationship between these answers as well. So what I want to show you is we've got this original problem here, and this original problem is log base 4 of 60, or I'm sorry, log base 4 of 64. And look at what's happening here. So the original base was 4, and it seems to be that the new argument, whatever's inside the log here, is 4. That transfers over there. 64 goes over here. So what's happening is if I take the answer here equals 3, and I just kind of move this log to the denominator, the second log to the denominator, and I make this into a fraction, this actually is going to give me my answer. So 6 divided by 2 is equal to this answer here. So I can actually chop this log up into 2 separate ones. And notice what I did. I changed the base, and I changed it to a 2 because I know 2 goes into both of these numbers, 4 and 64. So if I change this to a log base 2 of 64 divided by a log base 2 of 4, I can chop that up into 2 answers, and it gives me the same exact thing. Let me show you one more, what we did on the second one here. So on the second one, same deal here. You can see that the argument here, 81, is in the first log, the base is in the second log, and we change the base into something that goes into both of these numbers. If I just take the second log and its answer with it, put it in the denominator, and then create this fraction here, it gives me the same answer is what I had originally had. Okay. So let's see if, let's check out one more example here and figure out like, why is this useful and why do we care that we can do this? Well, this property is useful because when you run into a log where it's not a nice, neat answer, in other words, a whole number answer, like we don't know what power of 4 off the top of our heads gives us 8. So 4 to what power gives us 8? That's the question. Well, 4 times 1 is 4, and 4 to the first is 4, and 4 to the second is 16, and 8 doesn't fall neatly into one of those answers. And so we would have to either estimate it or use a calculator or something like that. But with this formula, what we can do is take this log and break it up into 2 logs, and notice that 2 goes into both of these numbers. So I'm going to change this into a log base 2. Remember, the 8, the argument, goes in the numerator. There's that one. The base 4 goes in the denominator. And these are 2 really easy logs that we know the answers to. It allows us to eventually find the answer to our original problem. So let's go through this just step by step. So what I did was I took the 8 and plopped it up here. I took the 4 and created this log base 2 of 4, and it goes in the bottom. And I can solve these really easily, and that'll in turn give me the answer to the original problem. So log base 2 of 8 is 2 to what power gives me 8? Well, that's 3. Log base 2 of 4 is 2 to what power gives me 4? That's 2. This is actually my answer to the original problem. So that is equal to log base 4 of 8. So 4 to the 3 halves, or this is actually equal to 1.5 in decimal form. I know some of you are a little more comfortable with decimals. Log base 4 of 8 is the same thing as 4 to the 1.5 equals 8, just in a different form. And you can plug that in your calculator and check that and make sure it works. But so we can use this property to find logs that aren't necessarily nice and neat and pretty in a pretty quick manner. So let's go ahead and formalize this. This is called the change of base formula. And the reason it's called the change of base formula is because we're going to take something that we originally start with. We're going to actually change the base on that in order to solve it. The way that we do it is this argument in here goes up top. So the A goes up top. And it kind of makes sense. It looks like it's over top of the B. The B goes to the denominator. And we can change that into whatever log we want to. So for these examples, it made sense to change it into a log 2 because 2 goes into both of these numbers. For this one, it made sense to change it into a log base 3. So going back to our formal version, my A goes into the top, and I can change that into any log that I want. So let's call it log base C of this thing, divided by log base C of this thing, of whatever's in the bottom. And these are equivalent expressions. So it's really helpful. It's really helpful when we get problems like, for instance, this. And if you want to see a little cleaner version, a little color-coded, you can pause the video and check this out. This is essentially the same thing I just did. But if we want to evaluate these logs, like look at this log right here, log base 27 of 9. Well, I don't know what that is, and it looks like it might be pretty ugly. This means 27 to what power equals 9. Well, I can split that up into these 2 logs. So my argument here, the 9 goes into the top, my 27 goes into the bottom, and 3 goes into both of those numbers, so I can use that fact in order to change this into a much easier problem. So log base 3 of 9, I know that that's 2, because 3 squared equals 9. Log base 3 of 27, well, 3 to the third equals 27, and I've now found my answer by chopping that up into 2 separate logs, and that's the answer to this log right here. So that is equal to log base 27 of 9. All right, so let's look at this one. Same deal here. Log base 8 of 16. We don't know what power of 8 gives us 16. So we chop this up into 2 logs. And the first log, I know that 2 goes into both of these numbers here. So I'm going to change this into a log base 2. When I do that, log base 2 of this number, this guy goes to the top. And a log base 2 of this number, this guy goes to the bottom. And that allows us to break this into 2 much simpler problems in order to find our answer to this little bit more difficult question. So log base 2 of 16, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's 4. And then in the denominator, this is log base 2 of 8, so 2 times 2 is 4, times 2 is 8. That's 3 2's that we multiply together, and this is going to be my answer, 4/3. That's what log base 8 of 16 is. Or in other words, 8 to the 4/3 is equal to 16. And you can plug that into your calculator and check it if you'd like. So, one more thing to talk about here. It's called the standard base. So what I mean by that is in math or in our number system, we use these numbers and we actually use them repeatedly. So here are our numbers that we use repeatedly. If you think about what comes in the next slot, well, what comes in the next slot is just a combination of 2 of these numbers, and it is obviously 10, so it's a combination of 0 and 1. What comes in the next slot is a combination of 2 numbers, 2 of these numbers, 11, and then 12 and 13, and so on. And so how many of these core numbers are there? Well, there are 10 of them. So there are 10 of these core numbers. And so our standard, quote unquote, our standard base that we work in is base 10. And if you think about why this might have, we just kind of invented these symbols to represent particular amounts. But if you think about why, we have 10 fingers and 10 toes. And so this is directly related to, us as human beings. And so what's the point here? Why, who cares about what base we count in? Well, with logarithms, a lot of times we're working in base 10. And so if you see something like this, log of 15, well, what's the base on this thing? There is no base listed. And when there's no base listed, it's assumed that we're working in base 10. So log of 15 is actually equal to log base 10 of 15. And they're asking what power of 10 gives me 15. So why is this useful? Well, what this does is it allows us to find answers on our calculator. Our calculators generally, unless you have a little bit fancier calculator, our calculators generally can only work in base 10. And so if I have like a log base 12 of 100, well, I know this is not going to be a nice, neat answer here, and I can use the change of base to turn it into something a little bit nicer. And guess what base I'm going to use? I'm going to use base 10 because I know my calculator can handle that. So this is equal to log base 10 of this number up top here. So that's 100 over log base 10 of 12. And you might say, hey, that doesn't really help us. But in your calculator, if you plug in log and then type in the number 100, it'll spit out an answer. We should know the answer to the top part. The top part's going to be 2. But the nice part on the bottom is log of 12. It'll give you a decimal approximation. So I plug that into my calculator. Log of 12 is equal to about 1.079. And log base 10 of 100 is just 10 to what power equals 100. That's just 2. I can now plug this in and get an exact answer. So using these concepts, first of all, the change of base, which happened right here, and then the log base 10, which happened here, we can eventually figure out that log base 12 of 100 is equal to about, this is an estimate, 1.85. And that means that we can calculate any log because we can change the base and figure out the answer accordingly.